So in this example, what we're going to be looking for is we're trying to figure out what can I do here, what can I break this apart into to create two pieces that we need. First, let's write down what this is. If you're going to factor something, it means that you are going to, as we just said a moment ago, break it down into parts, and actually into two parts in this case. Two parts that can be multiplied to create this polynomial. So when we are done, we should have then something that I can multiply together that would create what we started with in the first place. So let's take a look. First thing I need to do is focus on the coefficients. When we did our problems a moment ago, we multiplied the coefficients first. So let's start by looking there. I have a 4, I have a 24, and I have an 8. For us to factor something, what we really want to look at is what do they have in common. So somebody raise your hand and please tell me, if I have the numbers 4, 24, and 8, let's start with this general question, what do they have in common? We'll start there before we narrow it down. Yahira? They're all even numbers, definitely. That is very helpful. There's a certain type of even number that they all have in common also that would be even more helpful for what we're about to do. Carly?
They're all factors of 4.
They're all not factors of 4, but they're all multiples of 4. 4 is a factor of all of them. And that's exactly what we need. So I don't need any more hands right now. But these are all multiples of 4, and that's where we're going to begin this process. Because these are all multiples of 4, I can factor out a 4. So go ahead and write a 4. We're going to skip a little space for the variable and then put the parentheses. And make sure you leave enough parentheses to write down the same thing that we had already written before. Now, I mentioned before this began that this is the reverse of what we were doing a moment ago. So instead of multiplying coefficients, what would the reverse be? Dividing them, absolutely. So here's what we do. To start this off, let's divide each of the coefficients by the 4 that they had in common. Divide each of the coefficients by the 4 they had in common. What is 4 divided by 4?
1.
Should give me a 1. Very good. How about negative 24 divided by 4? Negative 6. All right. And then 8 divided by 4?
2.
Positive 2, right? So make sure it's a plus 2. We have now taken care of the coefficients. There's nothing else we need to do there. But we still have to worry about the variables. So please follow along very closely with this part. This is where we start to have some difficulty. Again, we will look for what they have in common. I have x to the 5th, x to the 3rd, and x squared. Raise your hand if you see something that they all have in common. It should be something that's actually very, very obvious. Sadie? They all have the variable x. That's an x, that's an x, that's an x. Perfect. They all have x. Because they all have x, the same variable, I can take something to do with x out of this. But let's be a little more specific. X to the 5th means x times x times x times x times x. There's 5 of them. There are 5 x's multiplied together. Here there are 3 x's together. Here there are 2 x's together. If I want to look for what they have in common that I can take out, I have to ask myself, what exponent can I write here? And here are our options. I have 5, I have 3, I have 2. I'm going to take one of these things out. But here's what we're going to do with it to help us figure it out. If I was going to take out x to the 5th, it means that I would take 5 x's away from here, 5 x's away from here, and 5 x's away from here. Can I take 5 x's away from here?
Nope.
There's only 3, so I can't write x to the 5th. If I wrote x to the 3rd here, it would mean I want to take 3 x's away from here. I could do that. There's 5. I could take 3 of them away. I would want to take 3 x's away from here. I could do that. There's 3 of them. And I'd want to take 3 x's away from here. But can I do that? No. There's only 2 here. I can't take away 3 of them. So that leaves me with our general rule. Whatever the smallest exponent is, that is what you take out. And here's the way it works. Instead of adding exponents like we did before, we will subtract the exponents. I had 5, but I'm taking 2 of them out. So how many do I have left inside? I have 3 left. In the second term, I had 3 x's inside, and I took out 2 of them. So how many do I have left? There's only 1, so x to the 1st. Please be very careful in the final term. I had 2 here, but I took 2 out. So how many do I have left? None. There are no x's left, which means this is it. I mentioned that by factoring, we're breaking it down into 2 parts, a monomial, a polynomial, that can be multiplied to create this polynomial. Well, double check your work. 4 times 1 is 4. Add the exponents, 2 and 3 is 5. 4 times negative 6 is negative 24. Add the exponents, 2 and 1 is 3. 4 times 2 is 8. Add the exponents, 2 and nothing is 2. We have completely reversed the process of multiplying these to create their factors. This monomial times this polynomial, those are the factors of this original polynomial. Are there any questions right now for how this problem works before we look at one more together? Joe?
What would you do if you had more than one variable?
Great question. What if there was more than one variable? Well, you still have to take out what they have in common. So let's say this has an x, this has an x, but this one has an x and a y. Do they all have y? Then I can't take out a y. I would take out the x that they all have in common, but I wouldn't take out anything else. If they all had x and y, then I would take out the smallest x and the smallest y. Okay? It all depends on what they have in common. And they all have to have it in common. Any other questions? Ricky?
Instead of using a factor for
Great question. I love this question. For those of you that did not hear it, Ricky said, instead of taking out a 4, could I take out a 2? These are all multiples of 2. You could, but if you took out 2 instead of 4, you would have a 2 here, you would have a 12 here, and you would have a 4 here. Aren't 2, 12, and 4 still things that have something in common? They'd all have a 2 in common. You don't want anything in common when you're done. You want to always take out the largest number that they have in common. This way, 1, 6, and 2, they don't have anything in common. That's how I know I'm finished. Great questions.